I request the guests who are standing outside also please come inside and take your seats. We're just about to start the program. I would like to invite the guests onto the dais. Let me start with our chairman, Pragna Bharati, Dr. Tripuraneni Hanuman Chaudhary Garu. Please come on to the dais, sir. President of Pragna Bharati, V. Srinivas Garu, is just here, about to reach in a minute or so. He will be here on the desk. And then I request Dr. Vedam Raj. Please come on to the desk, sir. Srinivas Garu, please come on to the desk. Now, I request the guests to perform the Jyoti Prajwalan.
शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योति परब्रह्मा दीपज्योति जनार्दनः दीपो हरतु मे पापं सन्ध्यादीपं नमोऽस्तुते शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः.
Can we all stand for Vande Mataram?
Vande Mataram, Vande Mataram, Sujalam Supalam, Malayajasitalam, Sasyashamalam, Mataram, Vande Mataram, Suprajosna Pulakitayamini, Fullakusumita Drumadala Sobhini, Subhasini, Sumadhurabhashini, Sukadam Varadam Mataram, Vande Mataram. Koti koti kantha kala kala ninada karale koti koti bhujai dhruta kara karavale abala ke numai tabale bahubaladharini namami tarini ripudalavarini mataram Vande Mataram तुमि विद्या तुमि धर्म तुमि हृदि तुमि मर्म त्वं हि प्राणाः शरीरे बाहुते तुमि मा शक्ति हृदये तुमि मा भक्ति तोमरोई प्रतिमा घटी मंदिरे मंदिरे वंदे मातरम् त्वं हि दुर्गा दश प्रहरण धारिणी कमलां कमलदल विहारिणी वाणी विद्यादायिनी नमामि त्वां नमामि कमलाम् अमलाम् अतुलां सुजलां सुफलां मातरं वन्दे मातरं श्यामलां सरलां सुस्मितां भूषितां धरणीं भरणीं मातरं वन्दे मातरं वन्दे मातरं वन्दे मातरं भारत माता की धन्यवाद।
Yeah, please shift to this other side. ధన్యవాదాలండి పద్మజ గారు. May I request all of you to keep your phones in mute or switch off if possible, so that there won't be any disturbance in between, especially while Rajji is presenting his presentation, PPT. My name is Chandrasekhar. I'm the Joint Secretary of Pragna Bharati, Telangana. On behalf of Pragna Bharati and GP Birla Archaeological, Astronomical and Scientific Research Institute, I welcome you all for this evening's wonderful program. Now, before we start the program, for the benefit of those of you who are here for the first time, just few lines about Pragna Bharati. Pragna Bharati is a forum for nationalist thinkers that brings together scholars and thought leaders. This serves as a platform for scholars, thinkers, and professionals to engage in discussions and initiatives focused on Bharat's culture, heritage, and national interests. This is all done through seminars, webinars, and public talks. Our monthly magazine, Bharati Pragna, covers the content to foster clear, logical thinking and strong intellectual foundation for national development. Each year, an eminent person identified by the committee is honored with an award program, Pragna Puraskar. This is primarily based upon the exceptional work done by him or her in their own field of work, highlighting Bharatiya knowledge and values. Pragna Bharati is present and active on social media. I request all of you to subscribe and share so that the good work reaches many more people. That is briefly about Pragna Bharati. Now, to start the session, I request our chairman, Dr. Tripuraneni Hanuman Chaudhary Garu. We all know him as the father of telecommunication industry in India. We all know that. And he is 95 years young, as we always fondly introduce him, because of his energy and the time he spares for the Dharma cause. I request Sri Chaudhary Garu to start with the opening remarks.
नमस्कार। सब बोलिए नमस्कार। नमस्कार। जय श्री राम। 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 Good morning, good afternoon, good evening, etc. To you, sometimes you say good morning, evening. Whereas if you say namaskar, if you want to any time in anywhere in the cities. And you should always invoke Dharma, that's why Jai Shri Ram. Friends, in all our great literature like Ramayana, Mahabharata, Bhagavata, etc., every event is described differently than. In that, what nakshatras are there, what constellations are there, at what time Pattabhisheka has happened, at what time Bhishma died, and at what time Mahabharata was here, or how it is, everything is described. Without time, there is no literature in our ancient literature. It is unfortunate that we are not gathered to those works that great Bhandara of information. So, the Mahabharata time, when it is gathered, at exactly that time when Bhishma died, when Shekhar, when the people were born, barriers, who fell at what time, everything is described in that one.
Afternoon siesta. In villages across India, lives have stopped when sun is at its harshest. Shops close, farmers rest, and children nap. It may seem like just a habit, but it is also a cultural rhythm, a way of marking time in harmony with nature. The body rests when the sun is high and wakes up again with the evening rays.
More treaties on that one, for which he got a doctorate also. That's why one Dr. Vedam has. I got a Telugu version of that book, and recently I went and read it. Often I read that one. The amount of information, the amount of knowledge that ancient here, which constellation at what time, when did it rise, at what altitude it is there, etc. All those things are there. So today we are going to have a talk on the ancient, the Indian knowledge of the Khagola Shastra, astronomy. I will tell you, sir, I think you will introduce better than I am. So in this short remark, I will make over this to Srinivas. You are going to say something.
I think more than this, first of all, Namaskar, and apologies, sir, I came late today, and I think a full introduction is due from Dhanashekhar and you.
Now, as you're all aware, today's topic is ancient Indian astronomers, the mapping of the skies. Dr. Vedam Raj is going to talk about it. He has got a PowerPoint presentation as well. Now, just before that, few lines about him. It's customary for us to introduce our guest. Dr. Vedam Raj is a faculty member at Hindu University of America. He teaches courses on history, philosophy, and science in India with the focus on Indian history and astronomy. He has profound understanding of astronomy, mathematics, and cosmology. He holds a master's degree from IIS, Indian Institute of Science, Bengaluru, and then he has got his PhD from University of Oregon, USA. He has about 26 years of professional experience in power, electronic design, automation, and oil and gas industry. He has combined his engineering expertise with a deep study of the mathematics of orbits to investigate ancient Indian methods for predicting planetary movements recorded in Vedic texts and epics. He is also a co-founder of the think tank Indian History Awareness and Research. In short, it's IHAR. You can actually check on social media, on YouTube especially. You will find his presentations and his talks on the YouTube and IHAR YouTube channel. And by the way, he is also an astrophotographer. And I request Dr. Vedam Raj to start his presentation for today, this evening. Please. Yeah, I request. Table is okay. This table is okay.
If they can see from the back, maybe should move it also.
Is this blocking the view? This is fine.
It's okay.
It's okay. On the lights.
If they can read it from back, that's okay. Can you hear my voice through this? Can you hear my voice? It's okay? Yes? Okay.
Yeah.
Check. Is it okay? It's not loud enough. It is not. I'll use that handle. I'll give you this one. Namaste. It's a real pleasure and a privilege to come and speak at Pragna Bharati. So I thank all the organizers for inviting me over here to talk. Gildarji, Raghuji, and all the other luminaries over here. I'm truly honored, it's a privilege to come and talk. Thank you. Thank you for the opportunity. And so let me get started with the talk. So today's talk is going to be on ancient Indian astronomers' mapping of the skies. And let me straightaway launch into the talk. There's no prelude over here. We have many instances of astronomy, Jyotisha Shastra, in our Vedic literature. It's found in the Samhitas, Brahmanas, Arnyakas, Upanishads, Sutras, Vedanas, Upavedas, Siddhantas. We have a whole collection of astronomy in many, many places. So what we'd like to do today is to show the roots of astronomy. I'm not sure if you can read it from back there, the page will be so small. So over here, I put what is Jyotisha Shastra and over here modern astronomy. In Jyotisha Shastra, we are concerned with cosmology. The origins of life itself. We are concerned with earth studies, seasons, planets, and so on. Astrometry, position of nakshatras, position of planets. Planetary studies, comets, orbits of planets. Time studies on calendars. Astro studies, one part of it is predictive Jyotisha. Mathematics to model celestial movements. And the tools our astronomers use were various yantras. Now, if we take a parallel with modern, what we call as modern astronomy, this is also concerned with cosmology. How did the universe come into being and all these kind of things. Astrometry, position of stars and planets. Planetary science, comets, asteroids, exoplanets. Stellar astronomy, life cycle of stars. Galaxy formation, physics of universe, exploration of life. And the tools we use of telescopes, radio telescopes, space telescopes, and so on. What you see is a trajectory from ancient times leading to the modern discipline of what we call astronomy itself. And I put for you a timeline over here, which I covered in about 20 lectures at Hindu University of America, about 40 hours. It takes 40 hours to communicate this information. But in summary, we can show the growth of astronomy in a very ancient period of time in India. There is transference of knowledge from ancient India to the Fertile Crescent in 2000 BCE. There is a certain event that happened, the transfer. India progressed on in astronomy, and around 600 BCE there was transference of astronomy and other knowledge to Neo-Babylon. We can show that also with evidence. In India, the Siddhanta astronomy tradition became very strong, and there was transference to the Greeks and the Romans between 400 BCE to about 400 current era. Then we have luminaries like Aryabhatta and others who continued on this tradition. By 700 current era, Indian knowledge went to Islamic lands. After the Islamic invasions, they went over there. India progressed on with Bhaskara II and many others. In the 10th, 12th centuries, there was transference of knowledge from the Islamics to Europe itself. Then we have Kerala school and a whole lot of astronomy happening in India. transmissions to colonial Europe between 15th century to 20th century. Somewhere in the 1600s, 17th century, the telescope was discovered in Europe, and they digested all this information. They took everything as part of their own tradition. They left India with predictive Jyotisha, and they said that's all Indians have. They called it astrology, something they couldn't take. And they allocated to themselves all the scientific tradition which they said originates from Greece and Babylon. So I show the real roots of this based on the knowledge of what they learned and the history that we have. It takes a long time to cover this, but I wanted to tell you that at the beginning. So the evolution of Bharati astronomy. Initially, a whole lot of observations were made on the sky, celestial display in the skies, and woven with philosophy. This is a very early development. Eventually, the wisdom was encoded into stories with metaphors. That's how mass communication was done. Eventually, then you have. And later on, we see very advanced mathematics. By the time you come to Kerala school, you find very advanced mathematics theories for celestial body behavior. And so I'd like to talk to you about some of these things. Everything that I do is based on evidence. As a scientist, I can't afford to see something that does not have evidence. That is why I'm giving you evidence in almost every slide. So excuse me if it takes too long to do that. Where are the sources? We see the sources starting from, like I said, Vedas, Brahmanas contain astronomy content, Puranas are stories, and so many Siddhantas. Siddhantas are mathematical astronomy works. The ones I've shown in red font are no longer available. We have lost them. But we know they existed because others have cited them. Later researchers have cited these earlier Siddhanta works. That's how we know they existed. But we can only speculate what might have been here. What kind of mathematics might have been here? We don't know. Then you have Vedanga Jyotisha to Lagada attributed to him 1400 BCE. You got Ritigarga and the Saura Surya Siddhanta. Then several other Siddhantas, Paitamaha, Lomasa, Pulisa and Vashishta. Commentaries were made, Bhashyas written by Bharadamihira. That's how we know they existed, but they are not available with us today. So we have lost a lot of information, but luckily we have got some commentaries on some of these things, so we know what might have existed there. Going forward in time, Aryabhatta, who wrote Aryabhatyam, Arya Siddhanta, Bharadamihira, I already told about Pancha Siddhantika, Brihat Samhita. Bhaskara the first wrote a Bhashya on Aryabhatyam, so it's very famous for that. Brahmagupta with the famous works, Brahmasputa Siddhanta, which went to the Arabs, and that's how they learned astronomy through these works. And so on, going on to Aryabhatta the second, then going on to Bhaskara the second, who wrote Siddhanta Shiromani, then to the Kerala school, Parameshwara, Nilakanta Somayaji, and others who wrote these works. Ganesha Daivagnya in Maharashtra, Jeshtadeva in Kerala, and in Odisha, Chandrasekhara Samanta, who wrote these works. Why am I showing you these things? To show you a citation trend. Every one of these astronomers referred to earlier people who came earlier than them, and they're referring to their works, their methods, and expanding on it. We have a continuous citation trail from the very earliest works till the much, much later works. This shows the growth of astronomy in the country rather than being attributed to influences from Babylon, from Greece, and so on. So how did the colonial people get to know about this? They are an important part of the story. So Cassini, Lee Gentle, Euler, Bailey, Playfair, they initially encountered Indian astronomy through direct transmission mechanisms. And they were absolutely amazed at Indian astronomy. They said there is so much antiquity here, surely the whole world has learnt astronomy from these guys and all these kind of things. But then William Jones came along and he started controversies because he said Latin, Sanskrit and Greek are related. Why are they related? He proposed something called a Proto-Indo-European language from which these things have come. There must be Aryan migration or invasion and these kinds of things. So he said Vedic literature can't be that old. And that set a trend with Max Muller and everybody else who said Vedic literature should be from 1200 BC to 200 BC, all the Vedic works were done. So they doubted whether Indian astronomy is old, right? But we have got ancient instances over there. So all the distortions, everybody, the red font is against the antiquity of Indian astronomy. The ones in white font are the guys who accept the antiquity of Indian astronomy. A whole lot of controversy started. How old is Indian astronomy? It is far greater than linguistic theories. That is the problem over here. To give you an example, a professor called David Pingree, who's well known in the history of sciences, he passed away in 2005. So he had the audacity to write that in India, astronomers paid little attention to observation or theory, and he says mathematical astronomy was introduced into India from the West, meaning from Babylon, and he's also saying that the preservation of Greek mathematics is one of India's greatest contribution to the history of science. I want you to see the arrogance over here. The arrogance over here that Indians had zero to offer, but because they copied it from the Greeks, they preserved it. Because Greek knowledge was lost during Christianization of Europe, right? So Indians have preserved this knowledge according to him. So this is the kind of arrogance you find in the history of science written by Westerners. Where is the evidence? Rest of my talk is going to show you amazing things that our ancestors have done. Starting with, what did our ancestors observe, right, in the skies? We can go and look at some of the very ancient artifacts. I pulled out this one from Andhra Pradesh, the stone circles. The stone circles today are known to align with where the vernal equinox is. They wanted to align where the sun started vernal equinox. So the research studies done how over time the positions of these have changed to try to track something called precession of equinox. So we are finding very, very ancient expression of astronomy in these kind of artifacts itself. And we know that Indians have observed stars in the ecliptic. Ecliptic means the path of the sun. As the sun appears to go around the sky, what are the stars distributed over there? These are called the nakshatras. Indians observed that every day the moon appears over the eastern horizon at a slightly different time. Today if it appears at 8 o'clock, tomorrow it might rise at around, let's say, 8:45 or something like that. Therefore, the star in the background is different every day. They observed it takes 27 days approximately to come back to the same star. So they divided the ecliptic into 27 segments and they gave the names of the moon's wives. They said Chandra married the 27 daughters of King Dakshan and he visited one wife each day. That really was a mnemonic to understand the nakshatra model. So Indians had this Chitra, Vishaka, Jeshta and all these things. And if the full moon appears in the Chitra nakshatra, that month is called the Chaitra Masa. In northern India, it is the Paurnami. In southern India, it is the Amavasya. When Amavasya happens over that nakshatra, that gives a name. That's why it's offset slightly. Indians also wanted to track the movement of the sun. The nakshatra model is not good for that. So for that purpose, they divided the ecliptic into 30-degree segments, 12 of them called Rashi. That will mark the Shankranti as the sun enters into a new constellation, Rashi. That will mark the period of time. So Indians had a calendar system based on this. And these are the names of the nakshatra in our ancient books, Vedanga Jyotisha, Surya Siddhanta. And when the British came to India, they wanted to identify the principal star with Western names. For example, Kritika is Eta Tauri or the Pleiades, Rohini is Alpha Tauri or Aldebaran, and you have Mrigashirsha, Orion, and all these kind of things. And the names of the nakshatras, these are common throughout India. This is not something that developed in Punjab, it is only over there. We find the astronomy model is the same throughout India, from Tamil Nadu all the way to Assam, all the way to Punjab and to the east and so on. There are some regional variations. For example, the Ardhra nakshatra is Thiruvadirai in Malayalam and Tamil, right? So small regional variations are there, but the etymology of these words are still common. That is how we know that we have one common astronomy model throughout India. So what did Indians observe? They observed one such personage is Rishi Atri. He is immortalized in the Rig Veda because he observed an eclipse. And we might say, what's the big deal? We see eclipses in our lifetime, we might see one or two eclipses, right? So why is he immortalized for that? It turns out that this eclipse might have been somewhere around 4002 BC and so on. What we see is the Rig Vedic verse over here is talking about how Atri, by his fourth prayer, discovered the sun. He discovered the sun is concealed by darkness and so on. This is an English translation of a Rig Vedic verse. And this caused a lot of amusement for the colonial people. because the language used was Rahu and Ketu. So the missionaries came and said, Indians are so superstitious and backward and primitive, they don't even know why an eclipse happens. They think there's a demon called Rahu swallowing the sun. That's why it happens. It required Aryabhatta to explain what it is. Aryabhatta said, if we have the ecliptic, if this is the ecliptic, the plane of Earth's orbit, he knew that the plane of the moon, as the moon goes around the Earth, is offset by 5 degrees. So an eclipse can happen when there's a coincidence of these two things, the sun and the moon coming together, that forms a solar eclipse or a lunar eclipse. And Aryabhatta called this ascending node as Rahu and the descending node as Ketu. So he explained what this whole thing is all about, and it makes perfect sense based upon that. So what about Atri? Why is he immortalized? Tilak is there for the rescue here. Tilak says he interprets Turiyena Brahmana, that is the word used in the Rig Vedic verse over here, to mean by means of Turiya. It is an astronomical instrument mentioned in Siddhanta Shiromani, for example. It's like a quadrant. Like you use a protractor in high school to measure angles, a quadrant can be used to measure angles in the sky, right? So he's suggesting that somehow he has understood the phenomena of eclipse. Eclipse happens when the angle between sun and moon comes to 0. When the longitude comes to 0, that's when an eclipse will happen. Atri has understood that. He has understood that eclipse is on its way and the next Amavasya is going to happen. So he's predicted that. He also knows that it will lead. So he's got an instrument to measure the angles in addition. That is what he's remembered. These are examples of the quadrant. This is an example in China. This huge instrument that you see. In Muslim period, this is the kind of angles to measure the sky. This is in medieval Europe, and this is the one we use in India. India had these kind of instruments to measure angles in the sky. So these are the kind of things they would use to measure the angle and predict it. This is why Atri is remembered. He knew the phenomena. He knew you could predict when an eclipse would happen based on these kinds of things. Indians also observed transit, but it was routine in India doing these kinds of things. And to give you some hard evidence, occultations, when the moon covers a nakshatra, it's called lunar occultation. This is occultations. When the moon covers a nakshatra, it's called lunar occultation. This is related to why Chandra loved Rohini more than the other wives. It's related to the occultation phenomena. They observed comets. Comets are called Dhumaketu, right? Comets were there in many references, Rig Veda, Ramayana, Mahabharata, in all these works, including Sangamira Tamil works. They talk about comets in addition. Now the problem is, comets have long periodicity, so we cannot identify what these comets were that Indians observed. But from 12th century onwards, we can reliably say this is Halley's comet, that is that comet, this comet. But earlier comets, we don't know what Indians might have observed in these things. Now the amazing thing is, one of the first catalogues in the world of the skies was Varahamira. Varahamira formed a catalogue of comets by the appearance. Maniketu, Jalaketu, and all these things were the kind of comets. He categorized them by their appearance, by their color, how many tails they have, the straight tail, curved tail. And he said that he has referred to earlier sources to compile this catalogue. Something like 100 types of comets are in Brihat Samhita of Varahamira. That is how many he refers to. So you can imagine, much before anybody had a star catalogue or anything like that, Indians were cataloging these kinds of things in the skies. It's an amazing piece of work. Indians also observed solstices and equinox. In addition to all these things, they knew about solstice and equinox. This is very interesting for us because we can use it for chronology to try to identify when these measurements were made. In order to understand that, you must understand something called Milankovitch cycle. Our Earth, in addition to rotation once in 24 hours, in addition to going around the sun in 365.24 days, it is also doing this cycle, orbital cycle, from circular to elliptical in 100,000 years, or the axis of rotation. Earth appears to be tilted on its axis and rotating like this, right? From west to east every day. Where it is pointing to is Dhruva. That is slowly tracing a path in the sky. That is this cycle, 26,000 years or obliquity. This cycle is important for us because Indians always said when the vernal equinox or the winter solstice, as right here, that's, let's say it's Kritika. Kritika is at vernal equinox. But then over 1,000 years, the Earth's observation point has changed thanks to precision. And Kritika is there, but now I'm pointing somewhere else, right? So using this rate of change, I can now tell you about when was that observation made. The first thing is, how old is the book Vedanga Jyotisha? Several researchers try to date these things. Weber said 500 BCE, William Jones 1100, Tilak said something else. Dikshit came closest to 1400 BCE, and we make use of the information inside Vedanga Jyotisha, which says in the verse 6, winter solstice occurred when the sun and moon came together in Dhanishta Nakshatra. That is our data point. So Lagada is saying, when this happened, sun and moon came together in Dhanishta Nakshatra. So we have to see when in the past, when winter solstice happened, there was Dhanishta Nakshatra. I have simulated this in planetarium software. What you're seeing here is projection of Earth's latitudes, longitudes in the sky. They become celestial coordinates. Okay? So this is the celestial North Pole. This is the ground line, that is east direction, west direction. This is the north, celestial North Pole. South is towards you. Think of it that way. You have heard the story of Dhruva. Dhruva had an unhappy childhood according to Vishnu Purana because his father married a younger woman. One day, Dhruva wanted to sit on his father's lap. Younger wife, shoo, no place for you. And the poor boy is crying, goes to his mother. Mother says, Karma theory and all those things. But the boy cannot be consoled. He wants to do tapasya. He wants to ask Vishnu, what is my place in the universe? So Vishnu fine day comes and asks him, what do you want, Dhruva? But then after tapasya, he doesn't want anything. Vishnu tells him, after your time, I'll make you into a motionless star in the sky. Everybody will go in pradakshina around you. Your place will be highest, even higher than the Saptarishis. Basically, Vishnu is saying you will be the pole star. That is important piece of information. But Vishnu says one more thing. He says, your mother Sumati, she will be next to you. This is there in Vishnu Purana, book 1, chapter 12. Right? It says that your mother will be next to you. That is an important piece of information. If we look at today's Dhruva, Polaris, there is no companion next to that. So we want to find out when in the past was there a pole star with a companion next to it. So this is our time today in 2022 when I made this. This is Dhruva. There is no companion next to Dhruva in the celestial North Pole. If I go back in time to 2800 BCE, Thuban was a pole star. Next to Thuban, we find a companion. You should have some goose pimples going now, right? Because this is now connecting powerfully. It's connecting powerfully what our Puranas are saying along with the scientific evidence. People who say Puranas are written in the Gupta time frame in 500 current era, Vendi, Doniker and the others, they have to tell us how does this data point come there? Because, very important, we did not have a pole star in 500 current era. We did not have a pole star in the year 1000. We did not have a pole star in the year 0. We did not have a pole star in the year 500 BC. Neither in 1000 BC, neither in Lagada's time 1500 BC, neither in 2000 BC. The last time we had a pole star was 2800 BC. After that, this is the next pole star that we are seeing in our time. We are lucky that we have a pole star now. So this is an amazing thing. So somebody asked, when were the Mahapuranas written? Vedavyasa wrote that. Probably this is the time frame, around 3000 BC. Powerful piece of information over here. Now in Shatapatha Brahmana, Rishi Yajnavalkya is telling the Vedic practitioner how to perform Vedic rituals. In doing so, he is telling how to find the east direction. Because all the yajnas are done for Agni, for Surya, Deva and others. So we have to find the east direction for maximum auspiciousness. We want that. For example, if our guest is coming from that side, I can't say namaste over here. It's very disrespectful. I must point out the correct direction. And you may say, what is the big deal where sun rises? That is the east direction. But then we got Uttarayana, we got Dakshinayana. Sun is going northernmost point, southernmost point. Plus 23 degrees up to minus 23 degrees. 46 degree span. Where is the east direction? Is it here, 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 here and here? No. when the sun is on the celestial equator, that is true east direction. That is what Yajnavalkya is saying. He is saying you can light up your fire in the Kritika nakshatra because Kritika does not move from the eastern quarter. So that is our clue. Tilak pointed this out. Tilak pointed this out and said this is the clue to do this. And this turns out to be, if you take a look at this once again, we have 90 degrees, 80, 70, 60, 50, 40, 30, 20, 10, 0. 0 is the celestial equator, and I have Kritika right here on the celestial equator. This is the ground line. Okay? So when the Vedic practitioner wakes up before the sun rises, Brahma Muhurta, he wakes up, has his bath, it is still dark, he'll come outside and say, okay, I see Kritika over there. 1 hour later, the sun will come above the eastern horizon, wash out Kritika, but no problem, I know a straight line from there. I put my bricks here and I start the fire here. Right? That's how it was done. In order to simulate this, I had to go to 2982 BCE to simulate this. So the time of Yajnavalkya should be put to this time frame, 2982 BCE. We have got an ancient epoch encoded in several tables. Our Puranas are talking about Kali Yuga. Aryabhatta, Surya Siddhanta, Pulisa Siddhanta, Brahmagupta, even Albani is talking about that. Temples in Karnataka, Aihole talk about that. Cassini got some tables from a French explorer who went to Thailand, and he got some astronomy tables. He couldn't figure out what it is. He sent it to his buddy. His buddy is in Italy, the mathematician Cassini. Cassini studied that and said, this is a calendar, and this calendar has got an absolute date of February 18th, 3102 BCE, and the longitude of Ujjain. Why is it relevant? Because it is found in Thailand. The Siam tables are in Thailand. Those tables are referring to Ujjain's longitude in order to compute that. Later on, other Britishers, other Europeans, Playfair, Bentley, Colebrook, Burgess, they all studied Surya Siddhanta for the same phenomena and verified February 18, 3102 BC. This turns out to be a conjunction of planets. All the planets are clustered in the Revati nakshatra. And this is the start of Kali Yuga. I'm going to talk to you again about this a little later in the talk. I simulated this in my planetarium software. So over here, February 18, 3102, this is Revati nakshatra over here. Guru is Jupiter, Shukran is Venus, almost on top of each other. Chandra, Moon is over here, Surya, Sun is over here, and Mangala is Mars, Buddha is Mercury, Shani is a little outside, Saturn, and they're all clustered like this. So clear evidence that our astronomers were referring to this phenomena in 3102 BCE. We have the story of Aditi. I've only picked out a few things for you guys over here. Aditi is known to be the mother of the gods, a lot of things with her, but I am going to refer to Aitreya Brahmana. Aitreya Brahmana is associated with Rig Veda. In the Aitreya Brahmana, it says the yajna, the sacrifice, went away from the Devas. The Devas did not know how to perform any further ceremony. They were confused. They did not know where it had gone to. They said to Aditi, let us know the sacrifice through thee. Aditi said, Tatastu, but I'll choose a boon from you. They said, choose. She chose a boon. All sacrifices will commence with me and end with me. Very, very difficult to understand what this means. Tilak came to our rescue. Tilak came and said, our ancestors were observing a celestial calendar based on the stars in the sky. That calendar was working very well, but over 1,000 years or so, thanks to precision, the same thing I showed you, the nakshatra is not where it is supposed to be. If you say there is a certain nakshatra at the vernal equinox point, it is no longer there. So you don't know when is the auspicious time for your function. You don't know that. They are confused. So our ancestors have reset the calendar. They have reset the calendar to Aditi, and Aditi is saying, what is that question? Oh, sorry. Aditi is saying, the new year will begin with me and end with me. Right? That's what she's saying. The new year will begin with me and end with me. That is what Aditi is saying. So we have to find out what is Aditi in our astronomy nakshatra system and when was it on vernal equinox, because new year in India is always vernal equinox. So we have to find out when did that happen. It turns out that Aditi is associated with the Punarvashu nakshatra. Punarvashu nakshatra has got two stars, Diti and Aditi. Both of them were the wives of Kashyapa, right? So Diti and Aditi. In Greek tradition we call it Castor and Pollux. Castor and Pollux are Diti and Aditi. So in order to simulate this, I had to go to 6000 BCE. In 6000 BC, we see again 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. 0 celestial equator, we got the vernal equinox over here, and the longitude, we got Punarvashu. To simulate this, my dear friends, I had to go to 6000 BCE, 8000 years ago. Some of you must be wondering, what on earth? 8000 years ago, our ancestors had a calendar? They had a calendar? And before 1000 years before that, they had a calendar that got messed up. That's why they reset the calendar. That is the implication coming out of this. Now going further, one last data point, now two more. Surya Siddhanta is talking about a conjunction of the Mesha Rashi. This comes to 6779 BCE. Very incidentally, when the Greek traveler called Megasthenes, when he came to Magadha in 300 BCE, he said the Indians have a king list going back 6000 years. He mentions that. And this amazing thing in Surya Siddhanta is talking about the same thing over here. Ashwins, all of us know the story of Surya, right? Surya one fine day becomes super hot and his wife Sanjana couldn't take it. So she decides to abandon her husband and go to the cooler region. So she leaves her shadow Chaya in her place and goes to the cooler region. One fine day Surya discovers deception. He says, hey, where's my wife? You're not my wife. Then she says she's gone to the cooler region. So Surya also goes off to the cooler region. So Ravi Verma's painting shows that Surya took the form of a horse because Sanjana was hiding as a horse. In that union, the Ashwini Kumaras are born. They are associated with horse and other such things. Healer physicians. Now there is a Rig Vedic verse that says Ushas. Ushas is the goddess of dawn. She heralds the sun. Sun is going to come. It says, awaken the Ashwins. You don't awaken a grown-up man. You're awakening babies, right? Awaken the Ashwins for their share of the Vedic sacrifice. What we learn is Ashwins are born in winter solstice because sun has gone to the cooler region. That is when he is born. And Ashwins are coming with the sun at dawn. Surya is showing his children to the world, right? He's showing these are my children kind of thing. Awaken at dawn for heliacal rising. When did this happen? I had to go back to 7200 BC. 7200 BC, this is now minus 24 degrees. This is celestial equator, minus 10, minus 20, minus 24. The nakshatra and the longitude is Ashwini over here. Those of you who think this is utter nonsense or not easy to think, I encourage you to please Google for this. Once upon a time, 9,000 years ago on Google, rajvedam.medium.com, this is the only case where I have independent scientific validation. Okay? This is the only case where I have this. So there are a couple of papers came out in the year 2022 in Nature, very prestigious journal, where they talked about a solar flare. Such a big solar flare that we've never seen anything like this in the last 9,000 years or so. It literally wiped out almost everything on Earth. That's the size of the solar flare. I've correlated that with this story. Our ancestors who survived here, they've observed the sun has become very bright, super bright for a period of time, and after some time, Vishwakarma, Sanjana's father, he goes and chips away sun's brilliance, right? And that's how Surya becomes less bright again, and marital bliss will follow after that. So those things are basically in this particular story. I've correlated that story with the scientific evidence that we have. It's a smoking gun. That is really the smoking gun that tells about when this might have happened. So we got some pretty amazing things in our chronology if you take our astronomy. You can use this to rebut Aryan invasion theory, because Aryan invasion theory is saying that all the Vedic literature, Max Muller is saying Chandas period, Mantra period, Sutra period, Brahmana period, all these kind of things. And he's saying all composed 1200 BC to 200 BC. But I have shown to you here Brahmana literatures going back to 3000 BC, and we've seen Rig Vedic literatures going to Aditi and other things, 7200 BC and so on. So clearly we have a problem. Okay, Indians also inferred and encoded wisdom into stories, right? I'm not going to read much about this, but about cosmology. We know in the Nasatya Sutta, for example, the prediction. They're trying to understand how did all this come about. Today the cosmologists or the astrophysicists who talk about Big Bang theory and things of this nature through which things have come. So over here is saying there was nothing, no existence, no air, no heavens, what covered it, where was it, who's keeping, was there cosmic water and death that we don't know. There was neither death nor immortality, no day or night, only the one, Brahman, breathed windlessly, self-sustaining. There was that one and no other. It's like a prediction. Our ancestors are trying to understand how did this come about, so they make a prediction. But then they step back and say, let me correct myself, there's a correction over here. But after all, who knows, who can say where it came from, how creation happened? Devas themselves are later than creation. Who knows where it has all come from? He says maybe even the creator does not know. This shows to you the scientific acumen of our ancestors. They didn't say the world was created in 6 days and then God rested on the 7th day. Believe it or else blasphemy. They didn't say that. They were open. Their mind was open. They said, here is my idea, but I may be wrong. So this is the scientific acumen of our ancestors. They also conceptualized the time as cyclical, right? For example, Brahma and the cyclical universe, they conceived of a Chaturyuga system. Satyuga, Treta Yuga, Dwapara, Kali Yuga, in the 4:3:2:1. It adds up to 4.32 million years. It took 71 of them, which makes a Manvantara. And in this Manvantara, 14 of them make one Kalpa. Kalpa is a day of Brahma. And our Srimad Bhagavatam is saying that in one day of Brahma you have creation, and the night of Brahma you have got Pralaya, dissolution. So this is our ancestors' understanding of cosmology, that is cyclical time in about 10 billion years timeline. It's interesting to see how today modern cosmology predicts is 13.8 billion years. Very, very interesting to see how our ancestors saw that. Yes, this is the same thing in a different way I'm showing that. Whereas in science we are saying there was a massive expansion leading to this kind of an expansion. In today's physics, astrophysics, one of the models that is conceptualized is the Big Bounce model, a recurrent creation and destruction. There are scientists today who propose there was a pre-existing universe that collapsed due to gravity, and from this singularity you have a new Big Bang and giving rise to a new universe. This is a serious theory out there. And one such person is Roger Penrose. Roger Penrose is an astrophysicist from Oxford who got a Nobel Prize recently. So he says that there is evidence of a prior universe in our cosmic microwave background. And he got the Nobel Prize for his work in 2020. And he says an earlier universe existed before the Big Bang and can still be observed today. Observe the cosmic microwave background, some anomalies. He measured about 35 anomalies, and his theory is it has come from the prior universe. The prior universe black holes have led to the present universe generation. That's what he's saying. That's why we have a certain distribution of galaxies, stars, and other such things in our universe. Amazing theories from him. It's so amazing to see how it coincides with Indian ideas of recurrent universe. Our ancient scientists in cosmology also conceptualized multiple universes, multiverses. For example, in Srimad Bhagavata Purana, it's talking about how there are innumerable universes, Brahmandas. How many Brahmandas? Uncountable number of Brahmandas. And in this verse it is saying they move about like atoms in you, talking about Vishnu and saying these Brahmandas are like atoms, they're moving like dust inside you. This is the conceptualization of our scientists. I want you to think about that. They didn't think this is everything, this earth is everything. They're saying this Brahmanda has got so many things, this is not the only one. There are millions, not millions, infinite, uncountable number of Brahmandas moving like atoms. They have reduced that to the size of atoms and saying moving like atoms. Just think about it for a minute. It is that is what they are talking about today. And also in Srimad Bhagavatam, the story of Kakudmi and Revati. Kakudmi was a king who had a beautiful daughter called Revati, and he could not find a match for her because she's so accomplished. So he goes to Brahmaloka itself to ask Brahma, hey, have you made a match for my daughter? And who is that fellow? Where is he? So when he goes to Brahmaloka, Brahma is enjoying a Gandharva concert. So he stands respectfully till the concert is over. And the concert is over, Brahma says, come here, why have you come here? And he says, why have you come? Brahma starts laughing. And he asks, why are you laughing? He says, in the time you're waiting, 27 Chaturyugas are over on earth. 27 Chaturyugas is 116 million years. This is the concept of dilated time. In today's modern physics, we talk about dilated time. It happens if you travel close to the speed of light, or you have the presence of a super heavy mass. When you're in the presence of super heavy mass, space-time is distorted and time can slow down over there. Brahma is the creator. All of creation mass is concentrated in Brahma. If you're in the presence of Brahma, that's what will happen to your time. You won't know the passage of time. That speculation has come out somehow over here. I'm not saying Indians knew these things, but it's interesting to see how Srimad Bhagavatam has got these things. Yajnavalkya's cosmology in Brihadaranyaka Upanishad. So over here he's challenged by Gargi. Gargi is challenging him to know his knowledge of cosmology, and he's correctly saying that we have everything on earth is covered by water, water by air, air by sky. So he correctly calls out up to the galaxy and Brahman, he's saying about the cosmology. Infinity. Infinity is one of those things that cause great anxiety to the Abrahamic people. Abrahamic people believe that God created the world perfectly in 6 days and made man in his image. Creation is perfect. There's nothing wrong in what God has done. Infinity implies an incompleteness. It's not over yet. God could not have left it incomplete. This led to a lot of theological problems in Abrahamic systems, but ancient Indians had no problem. They conceptualized infinity in many, many different ways. And whether it's the Rig Veda, Shatapatha Brahmana, Brihadaranyaka Upanishad, Chandogya Upanishad and others, they are all talking about infinity, either metaphorically, symbolically, implicitly, explicitly, they are talking about infinity. Infinity is a concept woven deeply into our Indian ideas over here. For example, you know the Purnamidam mantra, which we talk about, right? Saying from infinity you take away infinity, it remains infinity, which is a mathematical reality. Infinity minus infinity equal to infinity, and things of this nature. And one more amazing thing, among the things that Indians knew, Yajnavalkya is asked by Gargi, "Oh Yajnavalkya, what is there above the earth and below the earth?" And Yajnavalkya is saying, "Nothing is there, Gargi, is only unmanifested space. Space without any form is there above and below." Clear understanding that earth is suspended in space. This is in contrast to ancient Egyptians or Mesopotamians or biblical ideas which thought that the flat earth is held by some pillars, and there are pillars that hold up the heavens, firmament. Sky is a firmament where you can see the stars from the heavens, lights and things like that. This is the model that they had for a long time. Our ancestors, clearly Yajnavalkya is 3000 BCE. He's saying we are suspended in space. I want you to think about these kind of things. It's amazing things that he talks about. He even expresses gravity. So the same Gargi is asking him about gravity. He calls it the rule of the immutable. He says under the rule of immutable, sun and moon are held in their position. Heaven and earth maintain their position. Even muhurtas, time, day, night, everything is held by that. Even rivers flow east and west. He is expressing gravity. He is expressing gravity many thousands of years before Newton tried to put mathematics to it. We are saying that Yajnavalkya has already talked about gravity. Evidence is over here. Even hints of heliocentrism. If you take a look at this particular word, Shatapatha Brahmana, you can't read it from back there, I'll read it for you. He's saying, sun strings these worlds to himself on a thread. He's saying the sun strings all the planets to himself on a thread. It's a clear expression of heliocentric ideas over there, that the sun that is sustaining all these planets and so on. Then in the same Aitreya Brahmana, it says, the sun never sets or rises. When people think sun is setting, it is not so. It having arrived at the end of the day, it makes night on that side and day on this side. Aitreya Brahmana is saying this. Sun is not setting or rising. It is only the illusion we get when the day and night on this side and that side are done. A clear understanding of the roundness of earth and heliocentrism has come about implicitly in these ancient works. And one more thing to observe is the logic and rationality. There's a causal hypothesis over here. When our ancestors said sun is stringing the planets to himself, they wanted to understand why are the planets moving in the sky. They did not say because God made it so. They thought everything must have a reason. What is the prime mover that causes these things to move? They speculated there's a wind. They said there's a wind that makes these things move. That was the way they proposed these things.
To us, we might say, no, there's no wind, that mistake, it's all gravity and things like that. But the important thing to take away is how they wanted a cause and effect relationship. They were logically, rationally looking for hypotheses that fit the phenomena they were observing. They understood the phases of the moon. For example, in Aitreya Brahmana, we're seeing the sun. The moon enters the sun on the new moon day. The moon is born of the sun. So clearly, when they saw the shape of the moon changing every day, they knew it is because of reflected light. Now, the Britishers said Indians had no idea about the phases of the moon. They thought Soma, the sacrifice, is just getting drunk on Soma, then it's full. These are metaphoric ideas over there. But clearly, the science is understood when you look at some of these things. In Taittiriya Samhita, it is saying the moon receives light from the sun. Clear understanding, that's a light play, that is what is making the phases of the moon. They understood that sun rays and cause of seasons and wind. If you go back to this Rigveda Samhita itself, it's talking about 7 horses are harnessed to that one-wheeled chariot. You can split up the sun into the spectrum and all these kind of things. It's talking about that and so on. We also have a heritage of stories. A lot of stories encoded wisdom, right? So we have very ancient knowledge encoded in the metaphor of stories. And these are called myths, mythology by the Westerners. But really speaking, it is far more than that. I'm not going to tell you these stories, but I have told in other talks, story of Chandra marrying the 27 daughters of King Daksha. It is representing the nakshatras, the sidereal month of 27 days. Chandra visited one wife every day. It implies the moon covers 13.33 degrees in a 24-hour period. How much does the moon travel in the sky? That is what it's covering. Chandra loved Rohini the most. They are showing occultation phenomena. Chandra was cursed, and the alleviation of curse by Mahadeva to waxing and waning. This is the 29.5-day synodic month. The story of Dhruva talks about pole star and about precision. I have talked elsewhere about Yayati. The story of Yayati comes in Mahabharata. It really is a reference to the Andromeda galaxy. I cannot tell you, we have no time to talk to you about this, but see my talks for this. Story of Surya, like I told you, is a massive solar flare that happened 9,000 years ago. So stories encode wisdom. If you have the key to unlock that metaphor, the story, the wisdom is clear. If you don't have the key to unlock the wisdom, your understanding is at a pedestrian level. You'll call it mythology. So anybody who says that mythology means you're at an ignorant stage. You haven't understood the key to unlock the system. So finally, tracking time. This is the mathematical genius of our ancestors. I'm going to a little bit of mathematics here, okay? Because they tracked not only time but also celestial objects. How did they do that? Again, I've talked to you about Pingree, the famous Pingree, who's saying Aryabhatta did not observe. In a paper he says that. But he's not sure. He's saying if Aryabhatta did not observe, how did he arrive at such accurate measurements? He says the answer is extremely simple. He used Greek tables. So this is what you find. They don't have evidence or any such thing. They just push an idea, others keep referring to him, it becomes a fact after some time. That's what happens. I'd like to now present to you the evidence whether we had measurements, mathematics and other such things to claim that Indians are tracking. We have 5,000 years of archaeological data as talking about measurements, right? We have so many yantras. Harappa got water clocks. These are the water clocks recovered from Harappa, right? They were used to measure time. And even Vedanga Jyotisha talks about that. Aryabhatta is talking about all these yantras, Chaya yantra, Dhanur yantra, all these things are used to measure the skies and various things. Varamira, in addition to these things, he's got graphical calculations, the way we do XY plots and things like that, he's got graphical calculations. Brahmagupta's got a few more quadrants and other such things, he's got these things. Bhaskara the first is talking about a circular platform. When I went to Lothal in Ahmedabad, I saw this kind of a thing that nobody understood what it is. But looking at that, it's clear to me the same thing Bhaskara the first is talking about. It's an astronomical measurement device. You would measure over there the angle when you saw vernal equinox or some nakshatra or star and so on. And Lalla was talking about armillary sphere, Mahindra Suri and so on. I was very lucky to pull this out of Flickr. This is perhaps in Rajasthan, the Kota Palace, This entity that you see here is the Armillary sphere. This is how Indians had a map of the skies in a device. Using that, they could predict where different planets were and different other things by rotating this. This is perhaps the only thing that it was called the Rajayantra in India. Maybe this is the only model that we have today. Most of them are in European museums and places like that. So I've given to you evidence that we had instruments. If somebody has instruments to measure something, we don't measure just for the fun of measuring. That means you have some numbers to represent some object in the sky. Numbers will be used with some mathematics. Do we have evidence of mathematics? Yes, sir, we have. If you go to Vedam Jyotisha, Rishi Lagada is talking about rule of 3. This rule of 3 in modern algebra is a by b, c by x, where x is unknown, cross multiply, you'll get this answer. But Lagada is saying, you apply this again and again to get the desired result. In other words, supposing Mars is here today, and 2 weeks later Mars has moved some distance in the sky. So I got the present position, the next position, the time it took. I want to know where will Mars be 2 months later. What Lagada is saying is, you apply this rule, then by little apply it again and again with that same sampling, and you'll find out where the final answer is. So this is what we call a iterative linear prediction of motion. But the sky is curved, right? Sky is not straight line, it's curved one. But what you're seeing is evidence that we were able to track these things mathematically. That has come out over here. Because space is curved, our ancestors found that you could not predict very well. So they had to have better methods. In order to handle the curved nature, they invented trigonometry. Now trigonometry, the Western claims are Hipparchus is the so-called father of trigonometry. But what he had was this, chord tables. These are chord tables. Chord is not trigonometry. From high school, you know, right angle triangle. This is trigonometry, right? This appears for the first time in Surya Siddhanta. 600 BC work that we have talks about trigonometry. It's Jya and Kojya which form these things. So clear evidence that Indians were using trigonometry in order to track the motion of skies. We even have sine tables. Surya Siddhanta has got recursive formulas based on which you can set up the sine tables in addition. It's one of the first things that we have, right? It's amazing that but you have these kind of things in Surya Siddhanta itself. Then we have functional approximation, the mathematics of functional approximation. Indians were using all these formulas to make predictions, but they found errors. For example, Aryabhatta, he was using something called linear interpolation for the sine function. That was not accurate enough because by the time you come to Bhaskara the first, he's got an analytic function for sine theta. By the time you come to Brahmagupta, he is using second order interpolation for sine theta. By the time you come to Madhava in Kerala School of Mathematics in 1300s, he has got infinite series for the sine function. What is it telling you, my dear friends? It is saying our ancestors were not happy with one simple formula. They didn't say Acharya Aryabhatta has done that, we don't have to do anything. Shastras are frozen in time, we just follow Shastra and not do anything. They didn't say that. They were on a quest for excellence. They were on a quest for accuracy. So they were constantly using these formulas, discovering there's an error, trying to understand that error, proposing an innovation to address that error and developing these things. There is evidence of observation, modeling and refinement. If you know mathematics, if you know history, you can clearly see these things in the growth of mathematical astronomy in this country. Alright, we now talk about how did Indians track the nakshatras. If Kritika appears after sunset over there, I can't go and tell my friend, go to the east, beside that big tree you see, that's where Kritika is going to be. Yeah, at 6 o'clock it will be there, but at 9 o'clock where will it be? Because of rotation of the earth, it will be somewhere over there. So how do you communicate with somebody where the nakshatras are? So Indians had a coordinate system. Just like our latitudes and longitudes, they had a coordinate system to track the skies. They had an ecliptic coordinate system. The path of the sun, that is the cutting plane. It cuts the plane into celestial, northern celestial and the lower celestial, upper and lower. If this is a star, they would measure the distance to this ecliptic and the distance to the zero longitude. The zero longitude coincided with vernal equinox. Vernal equinox at Ujjain. That was always a Siddhanta astronomers, that was a reference point. With that, they could compute these things. Where is the evidence for these things? You should ask me, where is the evidence for these things? In Surya Siddhanta. Surya Siddhanta chapter 8, it is talking to you about Swabhoga. Swabhoga was the coordinate system. It is talking to you about the various measurements. I think I have a slide on that, yes. For example, it has got numbers like 48, 40, 65, 57, 58. This is there in Surya Siddhanta. What are these numbers? These numbers refer to starting with Ashwini. Why does it start with Ashwini? Because Ashwini was at vernal equinox when this book was written. 600 BCE, Ashwini was at vernal equinox, so the list of nakshatras starts with Ashwini. So he's saying this 48 must be multiplied by 10, you get 480. That is an arc minutes. You convert it to degrees and minutes, you get 8 degrees 0 minutes. Because each nakshatra uniformly has got 0 to 13 and 1/3 degrees, Ashwini will be found over here. Within this, it is 8 degrees. Viksepa and Swabhoga. That's what Indians call for that. The next one is Bharani. Bharani, the number is 40. 40 times 10 is 400. 6 degrees, 40 minutes. That means this first window is 13 and 1/3 degrees. After that, 8 degrees, that is where you'll find, 6 degrees, you'll find the next star. That is how our ancestors did it. That is how our ancestors did it. You should be shocked because we don't learn this in our textbooks. We don't learn this in our textbooks. None of them talk to you about these things. But this is the kind of acumen our ancestors had 600 BCE. That is where this text is from. They are doing these kinds of things. And keeping track of the passage of time, they had the lunar and the solar calendars. And I think I have, this might, let me see if this is a simulation. Let me see if this works. I have a notoriously slow computer here. Okay, I won't waste time. So Indians had two things, the sidereal and tropical, called Nirayana and Sayana system. Okay, these are the two kind of methods that Indians followed over here. So Nirayana means from a selected nakshatra back to that nakshatra. Vernal equinox, today it's at, let us say it's at Kritika 2500 BC. When the sun completes one full year, it comes back to that place in vernal equinox. That is one sidereal year or Nirayana year. The Sayana year, on the other hand, referred to vernal equinox back to vernal equinox, calling the first of Aries, which means Mesha Rashi, Meshadi. That was the one coming back over there. That is how they followed. Why is that important? Where are the sources for this? Vedanga Jyotisha uses a Nirayana method, but it contains awareness of Sayana method. Surya Siddhanta has got both Sayana and Nirayana. Aryabhatta used Nirayana, but his followers later on used Sayana corrections. And later on, everybody offered both Sayana and Nirayana. The Panchanga got these things too. They were used for various issues in the calendar systems. I won't read all these things. But this led to a very great controversy, my friends. It led to a great controversy. If Indians had only Nirayana system, the Westerners would have been happy. But Indians also had Sayana system, and that caused a lot of heartburn for them. This because if you had Sayana system, then you must keep track of precision. Because with precision, that the change in the equinox position is going to take place. And they claimed Indians did not know about precision. And who was that worthy person who claimed that? We have to see the height of accomplishment on axial precision. I already talked to you about his axial precision. This is the thing. And Pingree, our good friend Pingree, is once again coming over here and saying, yes, Varahamira has noted that. Varahamira is around 500 current era. Varahamira is quoting Lagada, who's saying, what is the extent of the sun from Uttarayana to Dakshinayana? What is the extent of the sun? In 1400 BC. In Lagada's time, that is no longer true. And in Varahamira's time, it's no longer true. And Varahamira is asking, how is it possible? Because of precision. And they look at Pingree's language. It is not unreasonable. You don't write scientific papers with so much uncertainty. He's saying it is not unreasonable to suppose the idea of precision was introduced into India by the Greeks. though the parameters chosen by the Indians are their own. This man is uncertain. He doesn't know, but he's making bold claims over there that Indians are copied from the Greeks and so on. Now I'd like to show you some evidence. Did Indians know about precision? I'd like to show you that. The same story, the story I told you about Dhruva. Guess what Vishnu is saying? Vishnu is saying a station will be assigned for you Dhruva for a period of one kalpa. He's saying you will be granted the duration of one kalpa. What does that mean? Vishnu is not saying you will forever be there at the pole star. Your time is limited. Your time is limited. That is what Vishnu is saying over here. Clear understanding the pole star is not fixed. It is there in Vishnu Purana, 2800 BCE. Right? It's talking about that. Then Professor R.N. Iyengar is pointing out several other things. He's talking about how there is in Brahmanda Purana, there is a metaphor. The metaphor is like a potter's wheel. The potter's wheel is moving in the center, you have clay, that is moving very, very slowly. Right? He's using that as a reference to Dhruva. In Brahmanda Purana it is there. Then also in the Maitrayani Upanishad, there is a question this king is asking to the Rishi. Why is Dhruva drifting? In other words, they have noted that Dhruva has been drifting. And why is it drifting? That is what they are asking. So the drifting of the pole star and other things is clearly saying the North Star, understood by us as fixed, has changed its position. Clearly, Indians have observed this phenomena that is going on. Now, because it is alleged that Hipparchus is a fellow who knew about precision in 150 BC, Indians have copied from him, I went to investigate that. This is a paper that is talking about Hipparchus. So here Ptolemy is saying Hipparchus' works have not survived. But Ptolemy is quoting him. So Ptolemy is saying, Hipparchus is saying solstice and equinox move backward by 100th part of a degree per annum. 100th part of a degree per annum. So 360 degrees will work out to some 36,000 years. So precision rate according to Hipparchus is 36,000 years. And on the Indian side, we want to refer to Parashara and Garga. Parashara and Garga have been quoted by Panini. That means they are earlier than Panini. Western dating for Panini is 800 BCE, so these people are earlier. I think R.N. Iyengar has shown that Parashara should be dated to same timeline as Vedanga Jyotisha, which is 1400 BCE. Now, if you take a look at P.V. Kane's work in the history of Dharmashastra, he's saying, Garga says that the Saptarishis turn from nakshatra to nakshatra in 100 years. They stay for 100 years in each nakshatra, which Abhyankar has referred to, explained this as 100 years per nakshatra is 1 degree in 100 years or 36,000 years. This is the same figure that Hipparchus later quotes. We know that Garga lived much before this man. How did this information come to him? Through transmissions like library at Alexandria and places like that, they've got this kind of knowledge, quoting these things. In Surya Siddhanta, we've got a verse that says the circle of nakshatras rotates 600 times in a Chaturyuga. Right? That's what it says. It moves to the westward by 27 degrees, it moves up by 27, comes back to 0, again goes to minus 27, comes back to 0. This is what Surya Siddhanta is saying. If we interpret what is going on, one Chaturyuga is 4.32 million years. In that it completes 600 revolutions. That means 7,200 years in this particular moment. The Indians call this Ayana Chalana. The precision was called Ayana Chalana. So if you take 600 revolutions multiplied by 27 degrees, 4 segments, 1, 2, 3, 4. Multiply by 60 to convert it to minutes, multiply by 60 to convert it to seconds, divided by 4.32 million years, you get 54 arc seconds per year. This is Surya Siddhanta's estimate of precision is 54 arc seconds in a year. The modern figure is 50 arc seconds in a year. Friends, this is truly amazing. To give you an idea, if you take the adult person's fist and put it at arm's length in the sky, this is about 10 degrees in the sky. If you take your pinky finger, extend it to the sky, this is about 1 degree. We are not talking degrees. We are not talking minutes. We are talking seconds. So the precision changes the vernal equinox position by 50 arc seconds in 1 year. Our ancestors measured that. Truly, it's a goose-pimple moment that we were able to do things like this. And I teach this in my class, and I show Surya Siddhanta got 54 arc seconds. Vritti got an early period of time, he got 36 arc seconds in a year. Hipparchus quoted the same figure. In China, in 300 current year, the estimate was 72 arc seconds. Aryabhatta, he got 48 arc seconds. It is better than 54. The true figure is 50 arc seconds. Surya Siddhanta is an overestimate, Aryabhatta is an underestimate, but the error is smaller, Aryabhatta's. The Arabs copied Surya Siddhanta directly, so they had the same 54 arc seconds a year. Bhaskara II refined it better to 48.6, and later Patani Samanta Chandrasekhar got 49.17. Those of you who don't know Patani Samanta Chandrasekhar, please write it down. Google his lifetime and read about it. You will start crying or be amazed at the kind of person he was. He was completely unschooled in Western methods. Extremely poor man who read about astronomy from his father's library. And he discovered that all the books, ancient books, are out of date because, rather, they were not accurate because of precision. He took it upon himself to make bamboo instruments. He made bamboo instruments and naked eye observations and corrected all these ancient books, Aryabhatta's books and everybody's for his time, 1900. When he was 72 years old, that's the first time in his life the British commissioner showed him a telescope. He's not seen a telescope till he was 72 years old. And the height of glory for him was when the Puri Vishwanath temple accepted his almanac. It's much more accurate than anything they had. So do read about his lifetime. So with naked eye observations he made this. Why is it important for us? It tells us how our ancestors did that without telescopes. How did they do these things? That is why the methods of Patani Samanta Chandrasekhar, using classical methods, we should do a PhD on that to understand how our ancestors did these things, right? So that I hope somebody is actually doing that, but nobody is. Okay, keeping track of calendars, we got the solar month, the Rashi, the lunar months, we got these things. 5,000 years of time constants for calendars. 1 muhurta is 48 minutes, 30 muhurtas, ahoratra, 30 ahoratras is 1 masa, 2 masas is 1 ritu, 3 ritus is 1 ayanam, 2 ayanams is 1 varsha. Now the 360 days, right? Rig Veda also talks about 360 days. But then the shortfall was done by the Atiratras Yajna. This would be for 5 days when time is not counted. That's how that synchronism in the Vedic times, Rig Vedic times. Later on, Atharva Veda says the Rishi called Rohita, he created the Adhika Masa. He knew the mathematics on when a month should be inserted, intercalary month. Therefore, every almost 3 years, there will be in average the solar lunar year will be the same amount of time. Rishi Rohita is the one who did this. Panchanga is a 5-dimensional measure of time. Nakshatra, Tithi, Vara, Yoga, Karana. We know about all these things. But what I'd like to point out as an engineer to you is the calendar that our ancestors used, non-ideal elements. What are those non-ideal elements? Each of these behaviors can be computed on ideal behavior. For example, we can say Nakshatra will change every 13.33 degrees. That is uniform. I've divided it uniformly, right? I can say Tithi will change every 12 degrees. That is also uniform, right? It assumes a circular motion and those kinds of things. But our ancestors knew better. They did not take this ideal. My friends, I'm going to show you something amazing over here. If you take a look at this high school experiment, a swinging pendulum, you know that when the pendulum goes here, the velocity is 0 when the highest point of the swing. And over here, the velocity is highest because Earth's gravity is pulling it, right? So kinetic energy is maximum over here. We know this picture. Now the same thing can be applied to the sun and to the Earth. When the Earth is an elliptical orbit, when the Earth is far away from the sun, it's called aphelion. It slows down. When it comes closer to the sun, it's perihelion. It speeds up. So the Earth speeds up here, slows down over here. If this is the Earth and this is the moon, then when the moon is farthest away, it's called apogee, slowest. When the moon approaches Earth, it speeds up, it's called perigee. Right? This is the physics that we understand today from elliptical orbits, that it is not uniform. elliptical orbits are there. What is amazing is our ancestors have accounted for elliptical orbits before Kepler. Before Kepler came on the scene with elliptical orbits, they have accounted for that. I'm going to give you evidence for this claim. I made a claim here. I must give you evidence now. Take a look at this first thing, the non-uniformity of Tithi duration. This is from a book called Indian Calendar by Sival and Dikshit. Right? They have said Tithi is normally the time occupied by moon and the sun when the longitude increases by 12 degrees, that is one Tithi. But then they change. This is in Gatikas, Palas and Vipala. These are the times that ancient Indians used, or hours, minutes and seconds. What you're seeing is the average is 23 hours, 37 minutes. The greatest length of Tithi is 26 hours, 6 minutes. And the least length is 21 hours, 34 minutes. Indians knew this. Indians knew this. If you take a look at the Drik Panchanga, sometimes you'll find the same Tithi is there for 2 days. Sometimes you'll find one Tithi has been expunged, it is not there. You might wonder why all those things are. Those are all the non-idealities of the calendar. Indians knew about these things. Or you look at the non-uniform size of the month. These are by Arya Siddhanta and Surya Siddhanta. Days, Gatikas, Palas, or days, hours, minutes and seconds. You find these are the solar months, Mesha, Vrishabha, all these things are the months. And you see, some days are 30 days, 31 days, 30 days, 29 days, 30 days. They are keeping track. When does the sun go from one Rashi to the next? Depending upon where the earth is perihelion or apohelion, it is speeding up or slowing down. So the duration of the days also change. This is known to our ancestors and they are already tracking for these things. That is what you're seeing over here. Same with the nakshatras. The nakshatras are not of uniform length. The length of the moon's nakshatra, this is the mean, this is the maximum, and this is the minimum. And even the nakshatras, if everything was uniform, then everything is 13 degrees 20 minutes, 26 degrees 40 minutes. Like this you can keep adding all the nakshatras. But in reality we have two systems, the Garga system and the Brahma Siddhanta system. And you can see that they are not uniform. The spacing is not uniform. Even that spacing is different over here. So what I try to show to you is that Indians had non-ideal elements in their calendar systems, clearly accommodating the elliptical nature of the orbit. And why does that translate? Why do we care elliptical? Because slowing down and speeding up at different times, they've accommodated for these things. That's what we see. Now the last part of what I'm going to talk to you, I'm going to talk to you about mean position of planets. Somebody said as an astrophotographer, that is true. These are pictures that I took. That is Saturn, Jupiter, this is Mars to the polar cap and the lunar eclipse moon. I took it in 2018, pretty long time back. But I want to talk to you about how Indians knew the position of planets. How did they know position of planets? So the planetary theory, I'm going to talk to you about something called mean position, right? Once again, Pingri. Like Pingri is saying, Aryabhatta did not observe. How did he know about the mean motion for Aryabhatta? He says he's copied the Greek tables. That is what his claim is. I want to talk to you about Parashara. Parashara in the traditional sense, from Vashishta to Shakti to Parashara to Vyasa. That is the genealogy, right? That is the genealogy. But there is a work attributed to him called Parashara Samhita, which we don't know the original Parashara, somebody else has got his name to it. We don't know about that. That work has not survived either. But Professor Iyengar is saying that Adbhuta Sagar of Ballala Sena and Utpala, who lived in the 10th century, they have left a bhashya on these things, on his work. That is how we know about Parashara's work. And Parashara, also Professor Iyengar is saying, he lived at the same time as Lagadha, which is approximately 1400 BCE. In Parashara's work, we are learning Jupiter traveling 2¼ nakshatras in 1 year leads to good crops. This is a mathematical time constant. It is saying that in 1 year, Jupiter travels 2¼ nakshatra. If we take uniform motion, each nakshatra is 13 1/3 degrees. You know exactly what portion of the 360 degrees has covered in 1 year. You can compute the orbital period of Jupiter out of this, right? You know it is taking approximately 12 years and so on to do this. That's what I've shown the mathematics over here. It takes 12 years to do that. He's talking about Saturn. Saturn's path towards the 27 nakshatras is for 28 years. 1400 BCE, Parashara is giving us mathematical time constants in order to compute the planetary motions, right? That's what you see. About Venus, now Venus and Mercury are difficult because you must look towards the sun, the inner planets. So for a short time before sunrise in the morning or for a short time after sunset in the evening, we can see Mercury and Venus. We cannot make out it is going around it. Sometimes that is on the left side, sometimes on the right side, sometimes in the morning, sometimes in the evening. So count how many paths there are in the east and west, 3 routes, north, central, 5 routes and so on. If you add up everything, the period that he counted for Venus is 591 days. The modern one is 584 days. So Parashara's got even the path of Venus over here. Mercury was greatly in error, but he's got that also in addition. So it is clear that observational astronomy was followed in Parashara's time. This is enough to kick the Pingri out of the place, right? He said that Indians did not observe. Without observing in 1400 BC, how do you get these kind of time constants? Right? So clear evidence is there that Parashara has been observing. Next we go to Surya Siddhanta. It is saying in a Chaturyuga, how many revolutions of the sun, how many of the moon, 57,300,000 and so on, how many of Mercury, how many of Venus, of the moon, of Mars. All these time constants are given in Surya Siddhanta. These constants were known by every Siddhanta practitioner. All they had to do was remember these constants, then using back of the envelope calculation, within 5 minutes or less, they will tell you where is Mars going to be today. I'm going to show you how they did that. It's very interesting to see that. So those mean motions, these are the all the planets mentioned over here. How many revolutions in a Chaturyuga? You can convert that into daily mean motion by this formula. Every day, how much does the celestial body move? How many revolutions in Mahayuga divided by number of days in the Mahayuga multiplied by 360 degrees will give you daily mean motion. For example, the sun traverses 59 minutes, 8 seconds. Moon traverses 13 degrees, 10 minutes, and so on. So we understand all these things. So bottom line is telling you every day how much is this going to move in mean motion. Mean motion means it's averaged out and those kinds of things. Indians computed something called Ahargana. Ahargana was how many days have elapsed since some epoch. They select some epoch and how many days have elapsed from that. That is called Ahargana. So if you know, there's a process to do how many days have elapsed. Professor Bachandra Rao has given some examples in his book. So if you know the starting position, that is lambda 0 at the beginning of that epoch, for example, might be Kali Yuga. At Kali Yuga, where was that planet? That is my starting position, lambda 0. To that, I am going to take the Ahargana. How many days have elapsed in Kali Yuga till present day? 30th August 2025, how many days have elapsed? I know the daily mean motion from the constants given in Surya Siddhanta. I multiply that, add it to this, I know today's position. That is how Indians did it. This is the mean motion to find out where each planet can be found, the longitude for these things. So every Siddhanta astronomer used beginning of Kali Yuga as a starting epoch over here. So these are some examples. Aryabhatta, Brahmagupta, Surya Siddhanta, Aryabhatta the second, for the sun, Chandra and other such things we see it. And I've shown the daily mean motion of the moon for the sun, how much it is. Daily mean motion of the sun, moon for different planets is given over here. And this is how ancient Indians were doing these things. What is the zero reference? Anybody remember the zero reference? Zero reference was Kali Yuga time. What did I tell you? Planets were clustered. All planets are clustered in Revati Nakshatra. Indians took it as 0 degrees. At Revati Nakshatra, it is 0 degrees. That's what you're seeing. Siddhanta Shiromani took slightly different. Ravi and Chandra 0 degrees. Kuja, Mars and other things were 359 degrees, 357 degrees, close to 0. Surya Siddhanta took all of them as 0 as starting points, which means you can ignore the starting point. Lambda 0 is no longer relevant, it's just 0. All you do is Ahargana times the daily mean motion, you'll get where the longitude should be. That is how Indians did that. They also knew there's something called Desantara correction, meaning that if I made the calculation for Ujjain, my longitude if I'm in Kolkata is different. So they knew that a correction must be made. That was called the Desantara correction in addition from Ujjain to that. That is what they did here. Now this last one will stop very soon. I think I'm running late. I'm sorry, let me finish this very soon. They also had something called true position. True position was necessary because the mean motion is wrong. The mean motion is based on circular orbits, right? Average and circular orbits. So you won't find the true position. True position was found on epicycle. This is the deferent where the mean motion is found. The true position is found on the epicycle. And they had a whole lot of mathematics to do this. I'm not going to show you these things. I'm going to skip. They had something called Mandafala, equation of center, a lot of mathematics to do that, but eventually they could find the true epicycle. But what is important for us is the radius of the epicycle was expanding and contracting based on the quadrant in which they were. And that was necessary to accommodate for the elliptical nature of the system. Evidence comes from that from Aryabhatta. You see there are two radius given over here. Even in Surya Siddhanta, you see there are two radius given here, showing that depending on the quadrant in which you are, they will change the radius to accommodate for the elliptical nature of the orbit. So the Indian position was, you compute the revolution of Mahayuga at Ujjain, you know the constants, compute Ahargana, compute the mean position, compute the Desantara, use epicycle for actual position, additional corrections, and you know the true position where the planet is going to be. Great accuracy. Last topic, the comparison of Greek and Indian models. This is by the paper published by my friend Anil Narayanan, and he's talking about these things. He says the Greek epicycle model, they too had the same epicycle model, but they had constant radius. Indians had pulsating radius, depending upon which quadrant you were in. So he's compared the accuracy if you're computing the longitude of the sun. When I'm computing the longitude of the sun over 365 days, what is the error in the Indian model and the Greek model? Greek error is a dashed line, Indian error is a strong line. So you're seeing that the Indian error is very small compared to the Greek error, showing that the Indian model is much better. In fact, the British guy called Brennan in late 1800s, he studied the epicycle parameters and he said, Surya Siddhanta has got epicycle parameters that are so accurate near 3500 BCE. Anil Narayanan did some experiments to see when will the error become smallest. From 2000 current era, he went all the way up to 5000 BCE. Over here, the sinusoid, innermost one, error was the least. I don't know how to explain this. 5000 BCE, the epicycle model had the least error. This is what Anil Narayanan has discovered. It is truly amazing. I'm not claiming we had this kind of mathematics, but these are the facts. These are the facts over here. So in conclusion, what I've done, mapping the skies, I've shown to you starting with what kind of observations ancient Indians made. We saw a whole lot of them. I talked to you about cosmology and antiquity of measurements in ancient India. I talked to you about observational wisdom in stories. I talked to you about tracking time, how they track time and celestial bodies, Nirvana methods, precision, calendars, ideal, non-ideal, planetary theory, mean. Thank you so much. So if you like the stock,
Please.
Please go ahead. Point and say this is where it might have happened. Traditionally, based on our traditions, there are people who said a lot of encyclopedias. That's what I did as a kid. I just read voraciously encyclopedias. If you get some astronomy magazines, you may want to read those things.
Any suggestions?
So there's a magazine called Astronomy in the US which I recommend, but I'm not sure what magazine you'll get over here. But to go online and search for.
In your class, you told that Parashara BC 1800.
1400. Yes.
Sir, Parashara's son Vyasa, he written the Mahabharata before
Right.
BC 3108.
Correct. Correct.
How it is 1800?
Very good question. If you remember in my talk, I said this may not be Parashara's work. This may be somebody who's written that work and call it Parashara Samhita. It may be based on earlier work that is given the name Parashara Samhita.
Right.
Professor Iyengar has dated whatever the content of that work. We don't even have that work. What we have is Bhashya by Vallalasena and Utpala of 10th century. Professor Iyengar has referred to that and he's saying we should assign this person to the timeline of Lagada, which is around 1400 BC. So we are not claiming that that is the timeline of Parashara himself.
That's
Okay. Yes, sir.
Last,
Please. Go ahead.
we were talking about Dhruva and the story of 26,000 years and
Yes, yes.
these things. I have one more thinking in my mind. Whatever we are looking at, the Dhruva is not existing right now. It is existing some number of light years ago. It was existing. Now it is visible to us. Can we map the time, Purana time, to that timeline and explain the story rather?
That's what I've done. That's what I've done. What we have today is Polaris. Polaris is not the same pole star at the time of Vishnu Purana. When Vishnu Purana was written, it was Thuban. Thuban is another pole star. If you go in the precision circle, we'll find another pole star called Thuban. That had a companion next to it.
Wait, can we tell it in the terms of light years and whatever the
Not light
timeline
years.
now it is?
Not light years. No, there's no light years involved here. If you just take the circle, the precision circle, it is going from Polaris on this side up to Abhijit.
Yes.
Abhijit on this side. So it takes about 13,000 years to reach Abhijit, another 13,000 years to come back to our today's Polaris.
Yeah, that is.
So in terms of light years, if you want to know the distance, I have to do some research. I can't tell you like that itself.
Thank you. Thank you.
Thank you, sir, for your enlightening talk. I have a question. After the Kerala school, why is it that we don't find any known, for almost 400 years, again you come to Iyengar and all these people who are researchers. So why is it? Is it that our schooling systems changed or we lost? That was a question. I have a follow-on also, but this is the first question.
Let me answer that first, then you go see. So you've actually answered that question. In the historical tradition of mathematics and astronomy, we find a lot of great people who lived in northern part of India for a long time. But after Bhaskara II and maybe Ganesha Daivagnya over there in Maharashtra, we don't find much in the north thanks to Islamic invasion. The Delhi Sultanate followed by Mughals that really ravaged northern India, where the scholarly tradition was almost completely killed. But luckily the south put a block, Vijayanagar. It effectively stopped the Muslims from coming to the south. More than 300 years we had Hindu safety in southern India. Scholars migrated to the south and we see mathematics and astronomy thriving in southern India, all the way from 1500s till Kamalakara. Kamalakara 1700s. After that you have the British. And the British completely killed our system. Completely killed us. That is how we lost. That's how we lost. The Muslims on one side, the British on the other side.
So the second one, more a comment. I'm amazed at Lokmanya Tilak, who is a mathematician, freedom fighter, editor, lawyer, and I read his two books, Orion and the other one. I'm amazed at his detailed research. Some light on him, sir, will be very good for everybody also to know.
So I think you already answered much of it. Tilak, I think we learn in our history textbooks. He was a freedom fighter those days, said Swarajya is my birthright. That's what he's famous for that. He formed this newspaper called Kesari, where he was communicating his ideas. He tried his best to unite Indians, and I think he's the one who started Ganesh Puja also, all the Pandals in Maharashtra to bring the Indians out, come in a procession, Hindus, and get together. Before that, people were staying in their houses and so on. But thanks to Tilak, this kind of activity happened. Tilak was an amazing scholar, lot of mathematics, and he was also educated in the British system. So he knew all the nonsense that the Europeans were talking about Bharati civilization. So he wrote his works on these things. But even a great man like Tilak, unfortunately got deluded by the misinformation of those days. In those days, linguistic theory was so pushed so hard, everybody believed it, and even he believed in Aryan invasion.
Yes, he supported.
Even he believed Aryan invasion, and he believed Aryans had come from North Pole and the polar region and things like that. But doesn't matter, even the best of us make mistakes. Nobody is perfect. In spite of that, his methods and his ideas, his data are very important for us today to read and learn. Yes, sir.
Can you just make a comment about the scale of learning and research which is going on in Indian universities on astronomy?
Okay.
Just a comment.
I think there is some pretty good work going on in modern astronomy in several universities in Pune, several universities in different parts of India, TIFR and all these kind of places are doing good research in these. There are some pretty well-known names who are doing modern astronomy. But learning about our classical historical methods, I am a little skeptical how many of us are learning. We have IKS started in various places. IKS is there in various places and people are studying. People are experts in the Sanskritam literature. But in the historical tradition, that is where we fall short. Because so much misinformation is there, we have fallen short in the historical tradition. What I've shown to you today is mathematical historical development of astronomy in the country. This kind of perspective you will not find in our universities, unfortunately. But they're very good at going into what is Brahmasputa Siddhanta talking about, what is Surya Siddhanta talking about. They're good at going into details. Yes, sir.
May I add one sentence here? About the astronomy has come into the southern India. A few families have sacrificed their lives. For 14 generations, they have been maintaining the traditional knowledge of Indian Jyotish Shastra. One family, that is called Pidaparthi family, for last 14 generations, they are called Kashipats. And they have been doing this method, not only just writing the Panchangas, but making a calculations and then adjusting the parameters. Been doing, they are doing it. Recently, we remember one great Pandit, Shankar Balakrishna Dikshit.
Yes, I referred to him as
Beautiful. People may not have acknowledged him totally. I may be permitted to say, in 1890, that is almost 135 years back, at the time one announcement was given by some king, maybe Baroda Maharaja or somebody, whoever may write a great book on Indian astronomy, history of Indian astronomy, he will be given a prize. Several people tried, and that prize went to Shankar Balakrishna Dikshit, who has written the book in Marathi language. You know the amount that was given first prize? 450 rupees. At that time, 10 grams of gold was 1 rupee. That is of Indian rupees at that time, the first prize. Immediately, he was awarded 1,000 rupees also. So 1450 rupees cash award he got it for writing the history of Indian astronomy in Marathi. Almost it runs into several kilos of gold today if you value it. In 1960, another Director General of Meteorological Department, he is also Maharashtrian. He knows Marathi as well as English. So he translated that Marathi version into English. And recently, about 10 years back, actually one of the pundits who got that English version, he said, Avadhan Garu, I am not able to follow this English version. If it is useful to you, you can take it. 20 years back it has happened. I took it casually. 2 volumes he has given me. Every sentence is a jewel. ప్రతి వాక్యము ఒక రత్నం అండి. తెలుగులో చెప్తేనే ఆ భావన నాకు సరిపడ చెప్తున్నది. Then we translated into Telugu. When Sri L.V. Subramanian garu was the executive officer, he sponsored it It came into 2000 pages, printed matter in Telugu. Actually, what all the information now you have been covering, broadly it was covered in that book actually. It gives a preliminary at least understanding of ancient Indian astronomy. He has given several examples also about the yoga concept. Kurtaya sabhavinam, Tretaya adinava darsham, Dvaparaya bhisam, Kalaye sabhasthanam. Like that, all the yoga concepts which are mentioned in the Taittiriya Brahmana, that he given the examples. And about the Ramayana also, about the Aditi, when you are telling, Tato yajne samappedu rutu nanshat samatyayu tataschadvadashe mase chaitre navamike nakshatre aditi daivache punarvasa nakshatra aditi daivacha. That was mentioned there. Similarly, he has covered the historical aspects of Pandava time also. When Balarama has gone to the Tirtha Yatra, that was mentioned with the Tithis and Nakshatras. When was Virata was killed in the battle? It's in the early hours of 14th day. Drona killed Virat Maharaja. And Abhimanyu Vada in Tarvata. They did not stop at the sunset time. They continued the war in the night also. And the early hours actually he killed Virata, then he killed this Drupada Raja also. Those details with the specific information related to nakshatras, he has mentioned it actually. That the astronomical evidence is available with respect to these historical aspects. But actually where I am interested to say is, recently in Tirupati there are several universities are there, particularly nationals, that is previously Rashtriya Sanskrit Vidyapith. Now it is renamed as National Sanskrit University. We submitted a proposal to introduce this kind of things in their degree courses. And they started it. 3-year degree course, they implemented it. And in the 3-year course, actually all these aspects we have mentioned. About Aryabhatiya we have included. No, actually the number of revolutions, how the Hargana we have mentioned. That is called as Q and Guru. Q, Guru. A shortest form of explaining contributions and the opinions of Varahamihira about the Milechas, about the foreign astronomers. And also, all these things actually, whatever you have been telling now, I am fortunate to see there is a revision of my subject actually. Thank you very much, sir. Namaskar.
So, actually, he's himself a great scholar. He's Dr. R.V.S. Saudhanlu Garu. He runs an organization called Veda Bharati. He's digitized all Vedas. Many of the we are losing so concept. So he's digitizing it. He has a studio house and he's digitizing all of that. And he has translated books. And he's doing your service with regard to preserving our ancient wisdom. So that is R.V. Saudhanlu. I think he deserves introduction, proper introduction. I just got one thing to ask here. If Parashara was born in 1400 BCE, pardon?
He is not.
No, you are
Attributed to him. Attributed to the work is dated to 1400 BC, but given his name, but it is not him.
Yeah, so that is the issue. Because Parashara was the great grandfather of Pandava.
Yes.
So then the event dating will happen much later.
Correct.
That's a
Correct.
Add, a father's name can be Parashara and his grandson's name also can be Parashara and further grandson's name is also Parashara. Which Parashara has written, nobody knows actually.
There was no concept of junior, senior then.
I just had a simple doubt, sir. Firstly, I'm thankful for your knowledge, sharing of knowledge. My question is, sir, you said that when the sun and the moon occurs in the Dhanishta Nakshatra, we got the winter solstice. So you attributed it to around like some 4000 BC or some
1400 BC.
1400 BC. So my question is like it takes like after like 24,000 years of cycle, it comes again, right?
It will come again after 26,000 years.
So why can it not be like 25,000 BC, but you attribute to 1400 BC?
So we have to be conservative. Yes, because the cyclical phenomena is like sine theta plus pi, or pi by 2, right? Keeps repeating itself, n pi by 2, as n. So cyclical phenomena repeat itself. So in this cycle of precision, we are being conservative and saying 1400 BC. Your point is it can be 26,000 years plus 1400 or 2 times 26,000 plus 1400. Yes, nobody can say, but the other evidences show that activity was happening in India between 8000 BC till present day. So a lot of activity. If you say 26,000 years, then you'll have to provide the evidence that yes, these things are happening over there. Nobody can say yes or no, but a lot of data seems to be pointing to present time. We have to be conservative.
Yes.
It can't be...
Just one more question, sir. You said that Dhruva Nakshatra, companion star was there around like 7000 BC, right?
No, 2800 BC.
2800 BC, okay. So it got to drift apart, like since like last 4000 years, right? So can we date when they both came rather than when they started drifting?
When did it come and when did it start drifting? No, it's not drifting. Right. Yes. See, stars have got something called proper motion. All the stars that we are seeing here is part of our galaxy, Milky Way galaxy. All stars are going around the Milky Way galaxy, okay? It takes approximately 288 million years to complete one complete revolution. I have computed that as one Muhurta of Brahma. In one Muhurta of Brahma, it completes one circle around the Milky Way galaxy. So every star that you see is also going around, including our sun. Different stars are going at different velocities, right, around that one. So, but in general, these two are together. So after 26,000 years, if you ask, will they still be together? Mostly. But if they have a relative motion between them, it might have expanded the distance. We don't know.
So can we know when they have come? Like, like for example, like the Earth was created like some millions of years ago.
So the way they do it is through, there is the US has sent out a spacecraft called GAIA, if I'm not mistaken, GAIA, or maybe some other name, I might have forgotten. This is able to simultaneously track the position of thousands and thousands of stars. It has been doing this over several years. By doing that, they have a time-based movement of these stars. So they can use that in the models of trajectories of stars, work backwards, and try to identify these kind of things. I don't think we are there yet. But at some point, they'll be in a position to have a star atlas of the movement of stars. It's called proper motion, but they might be able to do it. But today we don't have that. We might. If you have sufficient data, we might be able to. My pleasure. Thank you.
Thank you, sir. You are doing great research, which all Indians have to be indebted to you. As our Edwin have said, I don't know academy or Indian education system will read this. But my small question is, we are using Panchangas. In Panchangas, they are giving the number of years, different epochs as well as the creation of they say Srushtyadi Gatabdaha and they give it. So whether have you studied those years, whether you consider that the number of years mentioned there they have the scientific base?
I have not studied in detail to give you a proper answer. But I know that the Panchanga, after our National Calendar Commission, I think it was in 1950s, Nehru at 1956. So at that day of night of Brahma, there's the Pralaya and the creation. So in that system, it comes to 4.32 billion years. 4.32 billion years for the day of Brahma. The night of Brahma is also 4.32 billion years, and you have a Sandhya period also. So it adds up to approximately 8.6 billion years. Science is trying to tell us that our evolution over here from the so-called Big Bang is about 13.8 billion years. These timelines are coming close, very, very close. See, the thing is, when we say the universe is 13 things are, but the good thing is the Indian timeline of periodic creation and dissolution matches very closely with what science is telling us. Thank you. Sure.
Sir, my second question is, any mention about the doomsday, sir?
Doomsday?
Doomsday.
What doomsday?
When will the earth come to an end?
So the doomsday kind of ideas have come from Abrahamic religions.
Yeah.
Abrahamic religions believe in the day of judgment, or the day of raptures when Christ comes back, or the day of Magdi when in the Islamic tradition he comes and all these kind of things. Dujjal, I think that's a monster they're chasing. So they believe that on the day of judgment, all the dead people will be raised and judged and that is our fate, 5 billion years from now.
Anything, sir? All right, we're just about to wind up the session in next 5 minutes. Before that, as a token of appreciation and to say thank you, Pragna Bharati likes to present some books to Dr. Vedam. And a formal ode of thanks followed by national anthem. First of all, let me thank Dr. Vedam Raj for taking time out of his busy schedule. He has actually spared time for us for a webinar a couple of days ago, and today again he is with us. Thanks so much, sir. Your talk on this topic was truly inspiring. It made us feel deeply proud of the vast knowledge and vision our ancestors had, blending science, observation, and spirituality in such a timeless way. Thank you for bringing their wisdom alive for us. Thank you so much. And I would like to also thank Sri Mrityunjay Reddy Garu, the director of GP Birla Archaeological, Astronomical and Scientific Research Institute, this one, for collaborating with us to conduct this program. And also Sri Ram Ramaswamy Garu of Venkateshwara Hotel for sponsoring refreshments. And Avadhanal Garu for taking care of the giveaways. And LV Subramanian Garu, the Chief Secretary of Combined Andhra Pradesh, for gracing the occasion. Thank you, sir. And last but not the least, each of you in the audience. Without you, this program would not have been a success. So thanks for being here. And also, like I said earlier, I remind you again to subscribe to our social media handles so that it reaches everyone and more people. Thank you so much. Now let us all stand for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलजित रंगा तव शुभ नामे जागे तव सुभाषिष मागे गाहे तव जय गादा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय भारत जय हिंद।